Hey guys, what's going on? Welcome back to another video, and in this one we're going to be solving a question where we have to find maximum distance to closest person. So we have to maximize the distance to the closest person. So in this problem we are given an array representing a row of seats. So we are given an array and we are given some seats, and if the value is 1, then that means that the seat at that index has been occupied, and if the value is 0, then it means that the seat at that index is empty. So for example, let's say we have 1 0 1 1 0 0 0 0 1, and we have to assign a seat to the next person so that the distance between that person and the closest person is maximized. For example, if we assign this seat at index 1 to the new person, then the distance between two adjacent people is going to be 1. So if we assign this seat, then it is going to be 1, and the distance between the left one is 1, and the distance between right one is also 1. So minimum value of 1 comma 1 is going to be 1. And what if we assign one of these seats from here? Let's say if we assign this seat here, so this is going to become 1. So the distance between the person to the left of this seat is 2 in this case, and the person to the right is going to be 3. So minimum of 2 comma 3 is going to be 2. So we have to maximize these values. So at the end we have to find maximum of this value 2, maximum of 1, and maximum of the value that is going to come from assigning this seat, and this seat. So maximum of all of these values, and that is going to be the maximum distance to the closest person. Let's have a look at another test case. So what if we have something like this: 0 0 0 0 and 1. In this case, if we assign this seat to the next person, then the distance is going to be 4. For this seat, the distance is going to be 3. For this one, 2. For this one, 1. So maximum of 4, 3, 2 and 1 is going to be equal to 4. So we're going to assign this seat to the next person. And for another test case, let's say we have 0 0 0 1 0 0 0 0 and another 0, another 0, another 0 and 1. So for this case, if we assign this seat to the next person, the distance is going to be 5, and we know that the distance will be less for these seats. And now let's check for these seats. So if we choose the middle seat, let's say this one, the distance is going to be 4 from the left and 5 from the right. So minimum of 4 comma 5 is going to be 4, and maximum of this value 4 and 5 is going to be 5. So we're going to assign this seat to the next person. Let's have a look at the possible scenarios that we can have when assigning seats. We can have a combination of these three cases. So for the first case, we have empty seats at the start of an array. For the second case, we have empty seats at the end of the array. For the third case, we have empty seats between two occupied seats. So for the first case, as you can guess, in order to maximize the distance to the closest person, we should pick this seat. So this seat is going to have a distance of 6. For the second case as well, as you can guess, we should pick this seat as it is going to have a distance of 6 again. For the third case, we should pick this seat as this seat has a maximum distance of 2 between two occupied seats, and the maximum distance is going to be max of 6 comma 6 comma 2, which is going to be equal to 6. So we need to deal with these three cases and find the maximum among these three, and that is going to give us the maximum distance to the closest person. Now let's try to design our algorithm for this question. Let's say we have this example where we are given this array, and as you can see, this array is a combination of all the three cases that we discussed before. So as you can see, we have zeros at the start of the array, and we have some zeros between two ones, and we have zeros towards the end of the array. And now let's try to design our algorithm and see how we can maximize the distance to the closest person. For our algorithm, we are going to use 2 pointers. So I'm going to use 2 pointers. So the first pointer is going to be left pointer, which is going to be equal to 0, which is at the start of the array. And second pointer is going to be right pointer, and it is going to be at the end of the array. So initially, using these 2 pointers, we are going to solve for case 1 and case 2. For our case 1, we are going to increment our left pointer till we reach an index which has a value of 1. So as you can see, when left is 0, we are going to keep incrementing it till we reach this value 1. So when we reach this value 1, we are also going to increment the distance. So initially, when left is at 0, our distance d is 0, and as we reach till this index 3, we are going to increment our variable d, and when we reach this index 3, our distance d is going to be equal to 3. So let's call this variable max distance left, and this is going to be equal to 3. And similarly, we are going to handle our second case after handling the first case, and we are going to decrement our right pointer till we reach an index which has a value 1. And similarly, we are going to use another variable. Let's call it max distance right. And when we reach this index, our max distance right is going to be equal to 2, and right is going to be here. Now our left and right pointers are going to be at indexes which have value 1, and we have solved for our case 1 and case 2. Now the remaining values are going to fall in our third case, and this third case is when we have empty seats between two occupied seats. So we have our left pointer here and right pointer here. So what we are going to do next is we're going to use another variable. So let's say it is I, and we set I equal to L, and we will keep incrementing I till we reach an index which has a value 1. So the next index which is going to have a value 1 is going to be this one. So our I variable is now equal to 8, and once I becomes equal to 8, we can find the seat which is at maximum distance from index 3 and 8 by calculating the middle index between index 3 and 8. And the middle index between 3 and 8 is going to be equal to 3 plus 8 divided by 2, which is going to be equal to 5. The distance of index 5 from the index 3 is 2, and the distance of index 5 from index 8 is 3. So minimum of 2, 3 is going to be equal to 2. We can also pick index 6 instead of index 5, as index 6 will have distance of 3 from the left one and distance of 2 from the right one. So we can either pick index 5 or index 6. It's just that the mathematical operation 3 plus 8 divided by 2 is going to give us the smaller integer. So we choose index 5. And once we calculate the minimum value of 2 and 3, which is 2, we are now going to calculate the global maximum value. So the global maximum for our case 3, let's call that variable as max distance mid. So we are going to find the maximum of current value of max distance and this value 2. So initially we assign it as 0. So the current value of max distance mid will get updated to 2. And now we are done solving for this pair at index 3 and index 8. And now we are going to move on to the next pair. To move on to the next pair, we are going to have to update the value of left pointer. So my left pointer is now going to become equal to the value of I. And now following the same logic, we have to increment I till we find another index which has a value of 1. So if we do that, we are going to reach index 10, which has a value of 1. And the middle index between index 8 and 10 is going to be this index 9. And the distance of index 9 between index 8 is 1. And similarly, distance of index 9 between index 10 is also 1. So we are going to find the minimum value of 1, 1, which is equal to 1. And now we compare this minimum value with our max distance mid. So this is smaller than max distance mid, which is 2. So we don't update our value of max distance mid. We can also find maximum distance between two pair of ones by simply finding the gap between two indexes and dividing it by 2. For example, if we want to find the maximum distance of the assigned seat between indexes 8 and 3, it is simply going to be 8 minus 3 divided by 2, which is going to give us 2. Because of mathematical operation, this 8 minus 3 divided by 2 is going to give us the minimum value between 2 and 3, which is 2. This is because 8 minus 3 divided by 2 is going to give us 2.5, and the integer smaller than 2.5 is 2. So this is a simpler way of finding the maximum distance of the assigned seat between two indexes. Now if we move on to the next pair of ones, our left pointer is going to come here at index 10, and using similar approach, our I pointer is going to reach index 13. And we can find the maximum distance of the assigned seat between these indexes 10 and 13 by simply doing 13 minus 10 divided by 2, which is equal to 1. And we can pick either this seat or this seat. And next we're going to compare this value 1 with this max distance mid, and 1 is smaller than 2, so it is not going to be updated. And now if we move on, and our left pointer is going to become equal to 13, and now it has become equal to right, and we would be done with our third case. Now we are going to find the global maximum value between these three cases, which is going to be maximum of this value 3, this value 2, and this value 2, and this is going to give us 3. So finally, we are going to assign the seat at index 0 to the next person. I hope this made sense, and now let's have a look at the coding implementation. This is what the code is going to look like for this problem. So as discussed from algorithm walkthrough, we're going to define three variables. So these are three variables: max distance left, right, and mid. And here we have defined our 2 pointers, left and right, left starting at 0 and right starting at the end of the array. The first while loop is going to calculate our max distance left and is going to increment left pointer till we reach an index which has a value 1, and similarly we are going to decrement our right pointer and increment the value of max distance right till we reach an index which has a value of 1, and these two while loops are going to cover case 1 and case 2. After we are done with these two while loops, now our left pointer and right pointer will be at a position where the value is 1, and now we move on to our third case. So for our third case, we are going to use another variable I, and we are going to increment it as long as the value of seats I is 0, and as we are finding empty seats, the value I minus left is going to calculate the distance tracked so far, and as soon as we reach an index which has a value of 1, we are going to calculate the value of max distance mid, which is going to be max of current value of max distance mid and I minus left divided by 2. I minus left by 2 is the minimum of the distance of the middle seat from the left occupied seat and right occupied seat, and for the case when there are two possible seats, this value is going to give us the distance of the smaller index from the left occupied seat. And once we set max distance mid, we are going to increment left pointer and set it equal to the value of I, and then we move on to the next pair of ones. And once we are done with this for loop, we are going to find the maximum of these three variables, the three cases, and we return that and we would be done. So let's try to run this code. So that got accepted, and let's try to submit, and that works, which is great. So I hope this made sense. Thank you so much for watching, and I'll see you in the next one.